So hi, let me introduce myself. I am Ashish from Learnbay. So we're going to discuss about Python today, and tomorrow we're going to have a case study on stock price. Okay, guys, let's start. So today we're going to discuss about Python. If you have any doubt, then you can ask me and we'll discuss. So first of all, guys, Python is a high-level language. What is the meaning of high-level language? Any language, that is written in the human understandable form, then you can call it as the high-level language. So there are different examples of a high-level language, like you can say, C, C++, Java, all these are the examples of high-level languages. The same way, Python is a high-level language. Now, if you see, like nowadays, you might have seen Python is very famous. Yes or no? And when it comes to data science, so like it is the, like that everybody is learning Python. So the thing is, why are we learning Python? That question, arise in mind, like why Python for data scientist or data analyst? Anyone would like to say something about this? Why Python?
Because it has many modules that like pandas and
oh, that is great. Great. So the reason is, Python, provides rich source of libraries. You call it libraries or packages, right? Rich source of libraries. So you don't have to worry about the logic and all. You can just, you have to know, a particular library, how to import a library and how to use a particular function. If you know that, then your task is done. So if I talk about, different source, different libraries, so we have, like we have NumPy. NumPy that we use to, perform the numerical computations on a very large data. It is used for numerical computations, like metric computations and all. Then we have, pandas. So pandas is used for data manipulation, to work upon the, tabular data. We use pandas like we do in Excel. So that for that we use pandas. Then we have matplotlib and seaborn. So matplotlib is used for visualization. Then we have seaborn. So seaborn is also used for visualization. And apart from that, we have different more libraries to work upon statistics, more advanced operations in statistics and all. So that is why Python is very famous. If you know a bit of these libraries, you can do advanced computations with less code. Okay, that is the beauty. You can do the advanced computations with the less code. NumPy, pandas, matplotlib, and seaborn. Apart from that, we have sklearn for algorithms and all, and for to work upon the text data. We have NLTK, SciPy, and so many are there. So what I'm trying to convey is we have rich source of library. That is why Python has been famous. Apart from that, Python is easy to learn. So anybody like who does not have any prior experience to coding, they can easily learn Python. Is it clear, my friends? Why are we learning Python, or why Python has been very famous in, when it comes to data science or data analyst? It is not only like data science or data analyst. If you know Python, like you can, it's a general purpose language. It is not like you can only work in data analysis or data scientist field. You can go into web development, app development, and different things you can do, game development and all. So if you know Python and you want to move any of the fields, then you can easily do that. So it's a general purpose language and you can do a lot. If you know Python, all you need to know is the particular libraries related to a particular field. Like for web development, you are going to, learn a different set of libraries. For, data analysis or data scientists, you have to learn a different set of libraries, and that's it. So if you want to work on data, then you can use this. In that case, also you can use Python. Clear? So today we are going to have an introduction of Python. How do we, write the code and all. So, okay. Yes, please. So first of all, let's talk about the data type to work upon in Python. First, what is a data type? So anybody would like to say something about data type?
It shows that any data is a type of a text or a number or a decimal
Yes, yes,
data
yes.
type such as that.
Yes, great, great. So if you see, guys, we can have a any kind of data. Data may be anything, yes or no? So before data, before data type, we should know what is the data. So if I say what is the data, data may be anything. Agree my point? Data may be anything. Anything means it may be a number. It may be, it may be text. It may be images. It may be audios. Okay. It may be videos or anything. Data may be anything. There may be many more categories. So when we work upon different kind of data, so to store in the memory, we have different kind of memory requirement is there, right? So for what do we do? What utility we have been provided with is the data type. Data type is nothing but it is a type identifier that tells on which type of data we are working. Okay, it is a type identifier of the data. So in Python, we have two types of data types. Okay, if I talk about the types of data types, we have two types. Number one, we have the basic data types. And the second one, we have the derived data types. So let's discuss first of all the basic data types, guys. So knowledge of data types is very important when we work upon in any language. It is not like Python, but in any language if you want to work in. So the knowledge of data type is very important. Okay. It is not basis, it is basic data types, guys. So in basic data types, first of all, we have integer. In integer, we have, any number, whether it is positive or negative, without a decimal point. Then we have float. In float, any number, whether it is positive or whether it is negative, with a decimal point. It's just a category. Okay, if any number without a decimal point, it is treated as integer. If any number with a decimal point, it is known as it is treated as float. Okay, then we have string. String is anything. It may be anything kept inside the quotation mark. Like we have single quotation, then we have double quotation, then we have triple quotation, and then we have triple quotation 3 times. So anything if we keep in this, that is known as a string. Then apart from that, we have complex. If we in complex, if I talk about complex, so any number or any number in the form of a plus bj. So it is known as complex. So we will see some examples of them. Then we have Boolean. In Boolean, we have true or false. So two values, true or false, and then we have none type. In none type, we have none. So these are the basic data types. Let's discuss what is the meaning of that, like integer, float, string, complex, Boolean, and none type. First of all, let's say we are talking about the integer types. So integer is what?
Sir.
Yes, please.
Yeah, sir. Apologies for disturbing. Sir, will you be touching upon the analysis part? I mean, the stock price prediction part today?
No. That is we are going to have
Okay.
tomorrow. Today I am going to give Python introduction.
Okay. Yeah, thank you.
Or
Sir.
different
Thank you.
libraries. Then you look Python like how
Mhm.
to work in NumPy, Pandas, Seaborn, and Matplotlib. Okay.
Yeah.
So
Sure,
that
sure. Thank
tomorrow
you.
you can understand how to plot a particular graph, or how to read the data from the file and all.
Mhm.
Okay.
Okay, sir. Okay. Thank you. Yeah.
You're welcome. You're welcome. So integer, integer is what? For example, I say a equal to 10. So now 10 is what? 10 is the value that I am storing in a variable a. Now you tell me 10 is what? 10 is a number. So if 10 is a number, it may be, integer, or it may be float. So we have the type function that tells us the type of any data. So if I say a print a, it is printing 10. Okay. And if I check the type of a, so it is giving us class int. It means it is of integer type. Int means it is of integer type. So any value that is, with any number without a decimal point is an integer. Understood? Now the same way, if I say, a equal to 0, and I say, print a and type of a. So again, 0 is also an integer value. If I say a equal to -10, and I say print a and type of a, so it is again integer. So can we say, like, if we have, any value that is what? Any number, whether it is positive, negative, or 0, it is an integer value, yes or no? So any number, positive, negative, or 0, will be treated as integer. Now let's say if I say a equal to, let's say 2.5, and I say print a and type of a. So this is the number with a decimal point. If I execute, you say like it is a float type. So any number, if it has a decimal point, it will be treated as float. It doesn't matter whether it is 0 or negative or positive. It says, if I say 0.0, 0.0, and if I say print a and type of a, it is again float. If I take a negative number and I say a equal to, minus 5.5, and if I say print a and type of a, it is again float. Fine. So can we say any number without a decimal point is integer? Any number with a decimal point is float? Agree my point, guys? So these two we have seen, like float and integer, integer and float data types. Now this string, let's say I am saying a equal to, and I say Python. Fine. And if I say print a and type of a, so string you can say text. It is class str. Str stands for string. So anything that we keep in the quotation mark is known as a string. If I make it in the double quotation mark, let's say I say a equal to, not the single but double quotation, and I say Python, and I say print a and type of a, it is again string. It is again string. If I put it in the triple quotation mark like this, and I say Python, and I say print a and type of a, it is again string. So what is the difference between single, double, and triple quotation? For example, the output that I want like this. The output should be like this. Python's class. In the output, I want this, single quotation mark. And I say a equal to, and I say, like this. Python's class. So if you see here, if I print a and type of a, it is going to throw me an error. It is giving me invalid syntax. Why it is giving me invalid syntax? The opening is the single quotation and it ends here. So interpreter understands, okay, the string ends here. Then again, we have some values. It is not, getting like what is happening further. Are you getting my point? So this is the opening string. Okay. And start of this string, this is the end of this string. And further, it is not understanding what is happening. So if we have single quotation mark as the part of the string, then we can cover the string in the double quotation mark. If I do like this, can you say we are getting the output Python's class? Fine. So if single quotation mark is the part of the string, we can cover the string in the double quotation mark. Now, for example, the output that I want is like this. Output should be, like this. This is Python class. So in the output, Python should be covered in the double quotation mark. Now, if I say A equal to, and I say this is, and then again I say, you know, Python, and I say class. And again I say print A. It is going to throw me an error again. Why? This is the start of the string, this is the end of the string. Then it is not understanding what is the meaning of this Python word here. Fine. So if we have double quotation marks as the part of the string, then we can cover the string in the single quotation mark. If I do like this in the single quotation mark and then execute, we are getting the output. Fine. So I hope you have understood like what is the difference between single and double quotation marks. So if I have the single quotation mark as the part of the string, I can cover the string in double quotation mark and vice versa. Now, what is the use of triple quotation mark? For example, I say, I have a multi-line string. So I say this is, this is Python webinar. And then I go to the new line. Okay. So it is like, stock price analysis. Stock price analysis we're gonna do. Fine. Then again, I say, we are from Learnbay, something like that. So if I have a multi-line string, if I say print A and type of A, so it is giving me the error. Why? So when we have multi-line string, so single quotation mark is not going to, understand what is happening. It does not recognize the new line character. So what we do, if we have a multi-line string, we cover that string in the triple quotation mark. That's it. Can you see? We are having the triple quotation marks now. I execute and we are getting the output like this. So if we have multi-line string, we cover it in the triple quotation mark. It can be single, triple quotation or double triple quotation. So this is the, string type. First of all, we have integer. Then we have, float. And here we have discussed the string values. String. Now we have the Boolean, or let's say the complex. If I talk about the complex, if I say A equal to 10 plus 20j, let's say. So anything in the form of like this, 10 plus 20j, A plus bj, it is treated as a complex value. It is a complex value. So when we have A plus bj, so 10 will be the real number and 20 will be the imaginary number. Okay, so 10 is known as the real number and 20 is known as the imaginary number. Fine. So it is a complex value. It can be, if you have a float value, it doesn't matter. For example, if I say, 2.5 plus 0.2j, something like this. So it will be still a complex value. It is still a complex value. Fine. So this is complex. So this is used mainly, by in the advanced mathematics when we want to work upon the real and imaginary numbers. Now we have the bool data type. If we talk about the Boolean, only true and false are known as the bool. If we write true, so T should be capital. Okay, it is a keyword in Python. So true we write like this. And if I say print A and type of A, sorry, my bad. So it is the Boolean. Can you see it is a Boolean type? Now, if I say A equal to false, so F should be capital and then I say print A and type of A. So it is a Boolean type. Fine. Now we have the none type. If you talk about none type, so none is the none type. If I say A equal to none, so it represents the null values or the missing values. Okay. And if I say print A and type of A, so it is of none type. Yeah. So these are the basic data types that we usually work upon. So integer, float, string are the main. Okay. And this Boolean.
Kajal?
Fine. Now the most important thing that Python provides is the derived data types, guys. So these are more important. So derived data types are kind of data structures that we use to store multiple values, at a time. If you want to store multiple values at a time, then you can use derived data types. In derived data types, first of all, we have a list. Okay, so what is a list? Anything kept inside the square brackets is known as a list.
लिंक ऐक ना तो काय म्हणजे
Fine.
स्टॉक प्राइस अनालिसिस युजिंग पायथन सांगते काय
Pardon?
स्टॉक प्राइस कशी अनालाइज करायची ना ते शिकून घे.
I'm not able to understand what you're saying. Do you have any question, please? Hello. If you have any question, you can ask me. Okay. So anything we kept inside the square brackets is known as a list. Yeah, Karthike, if you want to work upon the date time, we do use that in NumPy and Pandas, not in core Python. Okay. So if we use NumPy and Pandas libraries, there we can work upon the date time and object data type. Understood? So I'm going to come on that. Okay, we are going to discuss the NumPy and Pandas also. Fine. In core Python, we don't have date time or like we have module date time if you want to work upon the date time data. But generally we do that in NumPy and Pandas if we want to work upon the date time and object data. Now the list, anything kept inside the square bracket is known as a list, and it can store heterogeneous elements. Heterogeneous values. So let's say, for example, I say a equal to inside the square brackets, and I say 1, 2, 3, 4, 5. 5 values I have given, and if I say print a and type of a, so we are getting 1, 2, 3, 4, 5, and it's a list, right? So it can store the heterogeneous elements. For example, I say 5, it's an integer value. Then I say 2.5, it's a float value. Then I am saying, like Python, it's a string value. Fine. Then I say true, it's a Boolean value. Then I say none, it's a what? It's a none type. Fine. Then I say 10 plus 20j, it's a complex value. And if I say print a and type of a, so it is again a list. Fine. With the help of indexes, so list uses the indexing method. So indexes always start from 0, like this is 0, 1, 2, 3, 4, 5. If you want to access any particular element, if I want to get the first element, you can say 0 and I am getting 5. If I want to get Python, so 0, 1, 2. So if I say A2 and I am getting Python. So this way we can access the values, from a list. So it can contain the heterogeneous elements. Okay. And it uses the indexing method. Next, we have the tuple. So in tuple, anything kept inside the parenthesis is known as a tuple. Let's say I say a equal to, and here I say 1, 2, 3, 4, 5, and I say print a and type of a. It's a tuple. It's a tuple. It can also store the heterogeneous elements. For example, I say a equal to, and here I say, let's say true, then I say Python, then I pass a list here, let's say 1, 2, 3, something like that, and then I say 50 or something. Again I print a and type of a, so it's a tuple. Again it's a tuple. So it can also store the heterogeneous elements. It also uses the indexing method. The same way, if I want to access the first element, I can pass the 0 index. The index of the first element is always 0. If I want to get the third element, so third element, the index of the third element will be 2, and I am getting at the third, it is a what? It is a list. So list and tuple, both are almost the same. There is only one difference. In list, after definition, after defining the list, we can change the particular element, but in tuple, we cannot do that. In tuple, we cannot do that. So list is mutable and tuple is immutable. What is the meaning of mutable? We can modify the values. We can. What is the meaning of immutable? We cannot modify the values. Fine. So this is mutability and immutability. For example, I have a list and I am saying 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I am printing list. So this is a list because it is in the square brackets. Now what I do, I say LST of 0. I want to change the element. Instead of 1, I make it 100. And if I say print LST, can you see the first element is 100 now? Can we say like we can change the values in a list? Yes, Roshan, I will tell you. Yes. Can we say in list we can change the values? Now the same, let's try with tuple. I say t equal to, so let me go to the new cell. For example, I say tuple, I take a tuple and I'm saying 1, 2, 3, 4, 5. And I say, print tuple. So it's a tuple because it is in the parenthesis, covered in the parenthesis. Now I say, tuple of 0, it is 1. I want to change it to 100 and I say 100. And you say it is giving me the type error. Tuple object does not support item assignment. Item assignment is the equal to operator. It means once we define the tuple, we cannot change the element. Once it is defined, it is defined. Understood? But in list, anytime we can change the elements. So that is the only difference in list and tuple we have. Fine. So list is widely used. When we want to change the values at any time, we use the list method rather than tuple. Okay. Tuple is used in generator operations. Okay. Like generator function to create an iterator object. Yes, Roshan. That is a separate topic. Okay. So tuple we can use for memory efficient operations. Let me show you. Let's say I create a list. With the help of loop, and I say 1, 2, 3, 4, 5. So it is going to create a list of 1 lakh elements, 1 lakh values from 0 to 99,999. Okay, and if I show you the size, what is it taking? How much bytes it is taking? 8,24,456. Okay, how this much of bytes it is taking. Now the same I create with the help of tuple. And I say I for I in range. And I say 1, 2, 3, 4, 5. Fine. And then I use the same, like I check the size, how much size it is taking. It is taking only 112 bytes. Can you see there is a huge difference in the memory consumption? It is a list. It is a tuple. I am using a comprehension method to create a list of 1 lakh numbers and tuple comprehension to create a tuple of 1 lakh numbers. Okay. So this is the generator object. When we use the tuple comprehension, what it does, it is going to create the numbers when we ask for. Otherwise, it is not going to create the numbers. That is why it is consuming less memory. Whereas when we define the list comprehension, it is going to create all the numbers at one go. Okay. I'm not printing it. If I print, like my kernel will crash. Okay. It will take a lot of space. So it is going to create all the numbers, and that is why it is going to consume the memory, all the memory. Yes, Roshan, is it making some sense now? So tuple we can use for memory efficient operation, or like you want to provide the data that you want, it should not be changed. Some utility you want, like it should not be changed. In that case, you can use tuple rather than list. Understood? So this is list and tuple. Next we have the set. Anything kept inside the this curly braces is known as a set. Is known as a set. So what is the utility of set? It does not contain the repetitions. It does not allow duplicate values. It does not allow duplicate values. For example, I say 1, 2, 3, 4, 5. Any number you can pass, and if I say print A and type of A, so you can say it's a set. It's a set. Now I pass some repetitions. For example, I am saying, are we having some repetitions here? Yes or no? Some values, those are being repeated. If I print this set, you can say it is taking the unique values only. It is not taking the repetitions. Okay, so that is the utility of set. It does not take the duplicate values. It only allows the unique values. Fine. Now we have a dictionary. So anything, it is a very, very important, data structure in Python. Anything kept inside the curly braces, okay, in the form of key colon value is known as a dictionary. In the curly braces, if we directly pass some elements separated by a comma, then that is a set. But if we have anything in the curly braces in the form of key colon value, then it is known as a dictionary. Okay. So for example, I say my dict equal to, I say, for example, I want to store, like, let's say, name, and name has been assigned to, let's say, Roshan. Fine. Then let's say I have code, and code has been assigned to, like, let's say 105. Then let's say, address is, let's say Noida. And then, company, let's say TCS. Right? So this is a dictionary. If you see here, we have the key. This is known as the key colon, and this key has been mapped to this particular value, Roshan. This key is the code, and this has been, is matched up to, this value, this 105, something like this. Okay. Now let's say if I say one more key, let's say salary, and you say, like, say 95K. Okay, 95,000. If I say print my dict and type of my dict, execute. So we are getting a dictionary, and the type is dict. Dict stands for dictionary. It is the keyword for dictionary is dict. Fine. Now what is the benefit of it? For example, I want to get the name. So what can I do? I can pass the name, any key, as the index. I want to say name. So name is Roshan. I want to know what is the code. So if I say code, we are getting 105. For example, I want to know what is the address. We are getting Noida. Now what I want to know, like, what is the salary. We are getting 95,000. So that is, if we have a multi-layered data structure, want to store the value, like employee data or something like that, then you can use a dictionary in that case. Fine. So if you want to extract the keys, we have keys function, guys. If I say dot keys, it is going to give you all the keys. So in dictionary, we have keys name, code, address, company, and salary. If we want to get the values, we can say mydic.values. And we are getting all the values like Roshan 105, Noida, TCS, and 95,000. These are the values. So these are the basic and Terra data types in Python, guys. I hope it is making some sense. Any doubts till now, you can ask me, please. Shall we move ahead then? Now we are going to discuss the libraries now. A bit overview of the libraries. So let's discuss a bit about the NumPy. NumPy stands for numerical Python, guys. NumPy stands for numerical Python. Any library, when we use any library, okay, to work in NumPy, we have to import it first. Any library, if we want to use that particular library, first of all, we have to import. So what do we do? Okay, NumPy provides a data structure known as arrays. So, okay, so if we want to work upon the arrays, then we use NumPy. So now the question is, what is array? And what is the use of it? So array is a collection of, it is the collection of homogeneous elements. Fine. And why do we use arrays? So arrays are faster than list. Okay, so arrays are faster than list, and in list we can store the heterogeneous means of different type of elements or different data types. If you see here in the list, we could store different type of values. Yeah, like one is integer, float, string, and all. Okay, but in arrays we can only store the homogeneous means of same type, but array is faster than the list. Apart from that, okay, we can, with the help of NumPy array, we can compute the advanced sophisticated numerical calculations on the very large data. Okay, on the very large data. So first of all, how to import NumPy? How to import NumPy? So we say import NumPy. So this is, so now any operation, any function that we want to use, we have to say NumPy dot. Okay, and then for example, I want to create an array. We have array function, and here we can pass a list or something for which we want to create an array. For example, I am passing these 9 values. Okay, and if I execute, so this is an array. Fine. So any function, if I want to use from NumPy library, every time I have to write NumPy dot, and I can access any function defined in this particular library. So NumPy, it takes time, like to write NumPy every time. So to make it easy, what we can do, we can give a name like as NP. NP means like we have given some name. You can give any name as per your choice. You can say N or whatever. Okay, so import NumPy as NP. When we do like this, so we don't have to write NumPy every time. We can just write NP, and if I'm executing, I'm getting the same amount. Understood? So in NumPy is the library that we use to work upon arrays. An array is a function that we use to create an array. Fine. So this is an array. If I store in a variable, let's say array equal to variable name, you can take anything. And if I say print array and type of array, so you can say it's an array. It looks like a list, but it is not a list, guys. It is an array, and it is saying the class numpy.nd array. N means n-dimensional array. Nd array means n-dimensional array. Understood? And if you want to check the type of the elements, so you can say array.dtype attribute, and it is telling you integer 32. So all the values are of integer type. All the values are of integer types. Understood? Please tell me if it is making sense. Fine. So different attributes of an array everyone. So first of all, I am creating an array, np.array. And I am passing, let's say, this is the 9 elements I have. So we can say array.d type. It is going to tell us the type. Then we can say array.size. It is going to tell us the size. Size means number of elements. So 9 elements we have. Then we have array.ending. It is going to tell like what is the dimension of the array. So it is a one-dimensional array. It is a one-dimensional array. Now, what is a two-dimensional array? Let's say like the reshaping of an array. Reshaping of an array. So I have this array. How many elements it has? It has 9 elements. Now I want to reshape it in a 3x3 array. 3x3 array means 3 rows and 3 columns. It should look like a matrix. Okay. So to work upon matrices, we use arrays. Okay. And I want to look like, I want it to look like a matrix. So what can I do? I can use the reshape method, reshape function, and I can pass the dimension. I want 3 rows and 3 columns. Execute. And if I say array, can you say it is a what? It looks like a matrix. 3 rows and 3 columns. And remember, 3 multiplied by 3 is what? 9. So what is the product of the shape? The number of elements you have should be the same. If 3 by 3 is 9, here we should have 9 elements. If I increase one element, let's say 10, then it is going to throw an error. That is the value error, like it cannot reshape 10 elements into 3 by 3 shape. Understood? So it has to be like this. Fine. So now if I say array.ending, it will be a two-dimensional array. Two-dimension means rows and columns. When we have something in the form of rows and columns, it is treated as a two-dimensional array. Fine, guys. Now, creating different kind of arrays. So different functions we have to create different kind of arrays. First of all, we have np.arrange function. In arrange function, what do we do? First of all, we pass the start, then stop, and then step 3 values. 3 values we pass. So it is going to create an array of the values in a particular range. Okay, particular range. For example, I want to create an array. Create an array of the natural numbers from let's say 1 to 25. 1 to 25. Okay. Remember one thing, that stop value is excluded. Excluded means if the stop is 25, it is going to give us the values up to 24. If the stop value is 10, it is going to give us the values up to 9, like that. So what can we do, guys? I can say np.arrange function. So what is the start value? That is 1. What is the stop value? If we want up to 25, stop value should be 1 extra. And if we say we are getting an array of 25 values, 1 to 25. Fine. Now, if I say create an array of even numbers between 10 and 50. I want to create an array of even numbers between 10 and 50. Then what can we do? We can say np.arrange. And I say the start index is 10, stop index is, I have to take 1 extra, let's say 51. And now if you say the even numbers, so if 10 is the even, then next even number would be 12, yes or no? Then next, next even number would be 14. Then next would be 16. So step size we can pass to. It means it is going to skip one value in between. It is going to skip one value in between. You can say like 10, 12, 14, 16, 18 up to 50. We are getting all the even numbers. Fine. If I say array equal to, and if I say this, this is the array, and if I say array dot let's say size, so we have 21 elements. Now I want to reshape this array 21 elements like 7 rows and 3 columns, or 3 rows and 7 columns. So what can I do? I can say reshape it. Let's say 3 rows and 7 columns I want. You can see I have reshaped it into 3 rows and 7 columns. Fine. So this is the arrange function that we use to create the values like this. Now we have the random, we can create the array of random values. Before that, let's say this np.zeros function we have. So np.zeros, it creates the array of zeros. Array where all the elements are zeros. So how do we say np.zeros? And here we take a, we have to pass a tuple. Tuple means the square brackets, and we can pass the shape. Shape like, let's say 3 rows and 3 columns I want. We are getting 3 rows and 3 columns where all the values are zeros. And if you say the type is float, why float? By default, it gives the float value. We are getting the decimal point. If you don't want this decimal point, you can change the type to integer like this. Now all the values are integer. Fine. If I make it 3 by 4, so 3 rows and 4 columns you're gonna get. If I say 5 by 5, so 5 rows and 5 columns we're gonna get like this. So this way you can create array of zeros like this. Now you want all the elements to be 50, you can say plus 50, and you every element will be 50. That is why arrays are faster in calculation. I'm saying plus 50, and plus 50 has been added to each element one by one. We don't have to apply loop or something. Understood? If I want all the elements to be 50.7, you can do that, and all the elements are 50.7 like this. Please tell me if it is making sense. Now we have np.zeros, np.ones. So it is similar to this, what to call np.zeros. So what it does, it returns an array where all the values are 1. So we can say np.ones. Here we have to pass a tuple, and we can give the shape. Let's say 4,5 and execute. 4 rows and 5 columns we have got where all the values are ones. By default, it gives the float values. If you don't want the float values, you can change the type to integer like this. And we are getting all the values as integer. Now, if you want all the values to be 5, you can say multiply by 5 and all the values will be 5. Yes. Fine. So this is like np.ones, np.zeros. Then we have, np.I. This is used to create an identity matrix. What is the identity matrix? Identity matrix where the diagonal are 1 and rest of the values are 0. the diagonals are ones and rest of the values are zeros. So that is known as the identity matrix. So we can say np dot I, and here I say 3, 3. So we have 3 by 3 matrix we have got, where you can say all the diagonals are 1 and rest of the values are zeros. If I say, let's say 5 by 5, so again it is an identity matrix where all the elements are diagonal elements are 1, rest of the elements are 0. You want to change the type, you can say type equal to int and all the values will be integer. Like that. Okay, so this way we can create a different type of arrays. Then we can create array of random values. So in to create the array of random values, we have to use random module. We have np dot random dot rand, and here we pass the shape. np is the library, numpy library, random is the module inside the numpy library, and rand is the function that we use to create the array of random values. Okay, it creates the array of the given shape of random values between 0 and 1. It creates an array of the random values between 0 and 1. For example, I say np dot random dot rand, and this shape is like say 3 by 3 and execute. So it has created a 3 by 3 array where we are getting the random values. Automatically, randomly it has taken the values. So if we want to create an array of random values, then we can use np dot random dot rand. Okay, and we can pass the shape. If I say, let's say 3 by 5, so 3 rows and 5 columns we're gonna get of the random values always between 0 to 1. Now, if we don't want the float values, we want the integer values, then we can use np dot random dot rand int function, and here we can pass the start, comma, stop, and comma the number of values we want. Number of values we want. So for example, I say np dot random dot rand int. Between 1 to 50, I want 10 random values. So between 1 to 50, 10 random values it is giving me. Okay. Let's say 1 to 5, I want 10 random values. It is going to give me 1 to 5, 10 random values. So because 1 to 5, we cannot have unique values, unique integer values. We are getting the repetitions. So randomly it is giving us the values. Let's say between 10 to 50, I want, let's say 25 random values. It is giving us 25 random values. If you want it to look like a matrix, then you can reshape it, and you can say reshape, and you can select 5, 5. It's a 5 by 5 matrix of random values we have got. So to work upon the arrays, we use the numpy module. Is it making some sense, guys? Please tell me. So we can create different kind of arrays with the help of numpy. So what is the use of numpy in when it comes to the data analysis or data science? See, sometimes what do we need to do? We need to create a column or row, of different numbers. So with the help of NumPy, we can easily do. As a data scientist, sometimes what do we need? We need to, check the accuracy of our model on different values. And then what we can do? We can create the arrays of different numbers, different type of numbers, and we can feed that to our model to check the accuracy. We can do that. Fine. Is it making some sense? Shall we move ahead? NumPy is widely used in space research, etc. Because there, calculation is very important, accuracy is very important, and sometimes they need to work upon the very large, numerical data or numerical numbers. So in that case, they use NumPy or such fields or similar areas. You can see. What is the other use of NumPy? Data may be anything. Okay, any kind of data can be converted into arrays of numbers, and then we can manipulate that data with the help of NumPy. Okay, so that is the use of NumPy mainly. Fine. Now next we have the pandas. That is very important library. Okay, so pandas stands for panel data, guys. Panel data means tabular data. When we have the data in the table format, okay, it is used to work upon tabular data as we do in Excel. Fine. So to use pandas, to work in pandas, first we have to import. So how to import? We can say import pandas. Then again, any function, if I want to access from pandas, every time I have to write pandas. So what we do, we can give a name, let's say PD. So now I can access any function related to pandas with the help of PD. I don't have to write pandas and pandas every time. Okay. Now we can check the version of pandas. So we can say PD dot underscore version underscore. So this is the pandas version. The same way you can check the NumPy version also, NumPy dot underscore version underscore, and you are getting the NumPy version. Okay, so different versions are available. So if you want to check, you can check the version also. So in pandas, we have we work upon two type of objects. Number one is the series object. And number two is the data frames. So let's talk about the series. What is a series? It is like a 1D array structure. It can be treated as a single column of a table in Excel sheet we have. If you say in Excel sheet, we can have different kind of columns. Okay, different columns. So single column can be treated as a series object. Okay, now how to create a series? How to create a series? So we can use pd.series function, and here we can pass a list, we can pass a tuple, or we can pass a dictionary to create a series. Fine. So let's create a series. Let's say I say pd.series. We can pass array also. Okay. Let's say I have an array. I say array equal to np dot arrange. Okay. Or let's say np dot random. dot rand in, and between let's say 10 to 50, I want 10 values. Okay. If I say array, this is the array we have. Now I want to convert it into a series object. I will say pt.series, and I can pass this array. When I say series, so it has, if you see, it has created a series. So these are the values we are getting 11, 29, 31 that has been created by an array, and on the left side we are getting the indexes. Let's say I give a name, let's say ser equal to, and I say series. So we are getting the series. Okay, here we have the indexes, here we have the values. If I want to access a particular element, I can pass as the index like 0. At the 0th index we have one element. If I say 5, at the 5th index we have 16 elements. Understood? So this is the series object. It is a single column, you can say, in the in an Excel sheet or in a table, we can say. Fine. So this way we can create a series of different types, different values. We can sort a series also. So we can say ser dot so if you can see, like it has sorted in the ascending order. Yes or no? The series has been sorted in the ascending order. If you don't want the ascending order, you want in the descending order, you can say ascending equal to false, and you are going to get in the descending order. So this way you can do different operations on a series object. So with the help of array, we have created a series. Yeah, series can be anything, Sujita. Like it doesn't matter whether we have homogeneous or heterogeneous elements. If we have heterogeneous elements, then the type will be object in that case. Okay, the type will be object. Let's say this is the series. Okay, this is the series we have, and let's say the 5th element, I make it I make it A, and if I say series, can you say the one element is A? Earlier the type was integer, the type is object now. So here we had the homogeneous elements, the elements of same type, but here we have the different type of elements now. Right. So when we have heterogeneous elements, so the type will be object. Understood? Yes. Let's say the very first value, you want to make it a float value, you can do that. Just make it 4.5, let's say, and execute. And if I say series, the first value is 4.5, one value is string, rest of the values are integer, and the type is object. Any doubt? Yes, Sujita, is it clear? So it can hold the heterogeneous elements also. We can create a series from a dictionary also. And let's say I have a dictionary D equal to, okay, and I have the values like let's create a data frame. Let me show you the data frame first. So data frame is what? It is like a 2D data structure, okay, 2D array structure. 2D array structure, okay. It can be treated. It can be treated as a table, complete table in Excel sheet. Okay. As we have the table in Excel, the same way we can, treat this what to call a data frame like that. Fine. So how to create a data frame? So we have pd.data frame, and again here we can pass list, we can pass tuple, we can pass series, we can pass dictionary. All these things we can pass. So I am creating a data frame. Generally, we use a dictionary. So I am creating a dictionary, let's say EMP equal to, and it is a dictionary. For example, I say name. So I have the employee data of a company and how many names we have, different names. So let's say we have, Roshan. Then let's say we have, Akshata. Then we have, Tim. Then let's say we have these a few names we have. Okay, how many names we have? 5 names, let's say. Then we have the corresponding codes. So how many codes we have? The same number of codes we have. Let's say 101 is the code, then 102 is the code. Then somebody, 103 is the code, 104 is the code, 105 is the code, like this. So these are the codes. Now we have the attribute, let's say city. So we have, different kind of city. They belong to different cities. Let's say he belongs to Mumbai. Then somebody, belongs to, let's say, Noida. Somebody, let's say, belongs to Pune. And, this from Bangalore. One, two, three, four, five. Okay. Now, let's say next we have let's say company. We can say he works in TCS. Then somebody works in Infosys. And he works in Kailash. And he works in SCL. And he works in. Right. So these are the companies. So if you say it's a dictionary, it's a dictionary. If I say EMP data, it's a dictionary. Now I want to convert this dictionary into a table. So what can I do? I can say pd.data frame. And here I can pass the employee. And if I execute, see, we have converted it into a data frame. So when we create a data frame from a dictionary, so whatever the, keys we have in the dictionaries, those become the names, column names, and the values becomes the values. So let's say this data frame name is DF, and I say DF. So this is the data frame we have created. Fine. So does it look like a table in Excel? So we have, it's a 2D structure. Why? Because we have rows and columns. On the left side, we are getting the indexes. So if you want to work upon, different attributes on the data frames, then you can say df.index, and you are going to get all the indexes. The start is 0, stop is, 5. So 5 elements we have in this. Okay, this is the index. Now, for example, you want to extract a particular column, you can say name. And it is going to give you all the values from name, like Roshan, Akshata, Tim, Nitin, and all. For example, you wanted to look like a data frame, you can pass the double square brackets and you are going to do them like this. Okay, so this is the name. Fine. So what we do, it is a small data frame. So I will tell you more on it. Okay, because ultimately we have to work upon the tabular data. So we can import a CSV or XLSX file in pandas. So how to import a CSV file? CSV is stands for the comma separated file. Okay, so we have pd dot read underscore CSV, and here we have to pass the path. This way we can import a CSV file. So if I show you, we have this Titanic data set Titanic.csv. So we are going to import because it is in the same drive. So I don't have to pass the path. I can simply do what? pd.read underscore CSV, and I can pass this Titanic dot CSV. this spelling mistake. And see, we have imported the CSV file that has 891 rows, 891 rows and 12 columns. So it is a data frame, it is a table. Yes or no, my friends? This is a table. So I will tell you how to work upon the tabular data with the help of this data set. So what I'm doing, I'm storing it in a data frame, let's say data equal to, and if I say print data, so this is the data. So we have total 891 rows. So in the between, it is just hiding some rows because otherwise, like sometimes we have millions of rows, so it is not going to print all of them. So it hides a few rows. It is showing the first few rows and the last few rows. So if you want to get the first, we have the attribute data.head. If I say data.head, it is going to show you the first 5 rows. Only first 5 rows we are getting. If you want the first 10 rows, you can say 10 and you are going to get the first 10 rows like this. Okay, we are going to get the first 10 rows. The same way you want to get the last rows, so you can say tail function and it is going to give you the last 5 rows. We are getting the last 5 rows of the data set. So on the left side, like 886, 887, 888, these are the indexes we have, and here we have the column name like passenger ID, server P class and all. Okay, now you want the last 10 rows, then you can say like 10 and you are getting the last 10. Fine. This is it. Now we have the info function. So it gives the basic information about the data. If I say data.info and execute, we are getting the information about the data. It is a pandas data frame. It has total 891 entries. It means we have 891 rows where the indexes of 891 rows is from 0 to 890. The first index is 0. The last index is 890. Remember, whether we use list, tuple, dictionary, not dictionary, list, tuple or array, series or pandas data frame, the first index is always 0 by default. The first index is always 0 by default. Then it is telling total 12 columns we have. This is the column index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is the column index. And these are the column names we are getting. Here we are getting the data type of all the columns, like passenger ID is the integer column, survived is the integer column. Then name is the object column. If we have in any column, if we have a string data or heterogeneous data, then it has been converted into the object column. Remember that. If we have heterogeneous data or string data, then the column of name or column data type will be object always. Fine. If you show at the bottom, if you see at the bottom, so it is saying like 2 float columns, 5 integer columns, and 5 object columns we have. So it means 7 numerical columns and 5 object columns we do have in this array. If you see a not null entries, so it is telling 891 not null values we have. It means we don't have any null values. But if you see the age column, so it means we have a few null values in this 714. It means we have a few null values in, right? So in what to call cabin column, if you see, we have a lot many null values. So we have to we have to do something about that. We will see. So this is the info attribute info function that is going to give some basic information about the data frame. Fine. Next we have the describe function. So what it does, it returns the statistical summary of the numerical columns only. Of the numerical columns only. So if I say data.describe and I execute, so we are getting the statistical summary of the numerical columns, like the count, mean, standard deviation, minimum value, maximum value, and these are the percentile value, like 25th percentile value, 50th percentile value, 75th percentile value, and so on. Fine. So we don't have to we don't have to separately check for the what is the minimum, what is the maximum, or what is the particular standard percentile value or the standard deviation. You just use the describe function and it is going to tell you the statistical summary like that. Fine. Apart from that, if you want to check the shape of the data, you can say shape. It is telling you 891 rows and 12 columns we have. Okay. If you want to know the column names, all the column names in the data, then you can say columns. and you are getting the column names. Passenger ID, server P class names, X, age, CBSP, parts, and ticket and all. Fine. Now, the most important is the handling the null values. That is the very, very important thing that we do actually with any data set. Handling the null values. So null values are the missing values actually. Null values are the missing values in the data. Okay. So if we want to do something with the null values, and those are represented np.nan and what else? So how to check for the null values? For that we have data frame name dot is null is the function is null, or we have data dot is null. Any function we can use to check for the null values, guys. Any function we can use to check for the null values. So let me show you. If I say data dot is null, execute, it is giving me the data frame of Boolean values. Where we have false, it means that value is not a null value. Where we have true, it means that is a null value. If you say like in cabin column, we have true. A lot many trues we have in the cabin column. So we have null values in cabin column, some trues we have. Some null values we may have in age column, like true we have here. But it is not easy to read, right? So what we can do, we can pass the sum function, and it is going to give the sum of the null values in each column. So you can say in each column we have 177 null values, and in cabin column we have 684 null values, and in embarked column we have 2 null values. Understand how to check the null values? The same way we can do data dot is na, and I say dot sum, and it is going to give me the null value. So you can use any of the function is null or is na. So if we don't use this sum, it is going to give us a Boolean data frame that is not easy to read. So we just pass the sum function. What this sum function does, it is going to count all the trues. Okay, the integer value equivalent of true is 1. So it is going to count all the trues, and where we have true, it means that is a null value. Fine. So this is how. Now we have got how many null values. So how to how to treat the null values? We have 2 ways to treat the null values. The first way, we can drop the null values. The second way, we can fill the null values with some other value. Fine. So both the options are there. We can drop the null values, or we can fill the null values with something. Okay. So first of all, dropping the null values. How can we drop the null values, guys? So we have drop na function. Drop na function is used to drop the null values. For example, if I say data dot drop na, okay, and execute, it is going to drop all the rows. Okay, it is going to drop all the rows where we have at least one null value. Now earlier, how many values we have in the data set, guys? If you see 891 rows we had, 891 rows we had. Now this drop na function has deleted all the rows where we had at least one null value. Now the data set has been reduced to 186 rows only. Now how many rows we have? 186 rows. So this is a very disastrous function. Why? Because it is going to reduce the size of the data, and that is not a good thing. For example, this particular row, if it has only one null value, the whole row will be deleted, and it affects the different columns, right? It is going to affect the different columns. So it is not the good idea to drop the null values when we have different null values. Okay, so many null values. And if I say data again, So you say again, I am getting the 891 rows. So what happens? It does not make the changes in the existing data set. If you want the changes to be made in the existing data set, you have to say in place equal to true. Remember, when you say in place equal to true, the changes are final. The changes are final. It means it is going to drop all the null values in the existing data set I executed. If I execute it, you can say in the data I have 186 rows. If I say data dot shape now, we have 186 rows. So this is a disastrous function, guys. So now remember, once we work in pandas, we don't have control Z. We cannot do anything undo. Once we do make any changes, the changes are final. Now, if I want to, I cannot get back all the rows which have been deleted. If I want them back, so I have to load the data set again. Getting my point? So what do I need to do? I have to load this data set again. If I say data, again we are getting 891 rows. And if I say data dot is null, dot sum, we are getting the null values. And if I say data dot shape, we are getting all 891 rows. So I have shown you how to drop the null values, and it should be avoided because it is going to reduce the size of the data. The other way around is what we can do, we can fill the null values. So we use fill NA function, guys, and here we can pass the value which you want to fill with. Fill NA function. So for example, in the age column, we have null value. So age is what? Age is a numerical column, right? Where it is a numerical column. So in numerical columns or discrete columns, what we generally do, we fill the null values with mean value or median value. Okay. With mean value or median value. So how to calculate the mean or median? We can say data dot age. We are getting the age, okay, a value of age in the age column. And if I want to get the mean, I will just say mean function, and we are getting the mean value. So mean is 39. If I want to get the median value, I can say data dot age and dot, I can say the median function I can use, and I'm going to get the median value. Fine, so median is 28. Now you can fill the null values with either mean or median, or you can fill with 0 or any random values. It doesn't matter. So let's say I want to fill the age column with the mean value. So how can I do that? I will say data dot age dot fill NA, and here I can say data dot, I want to fill the mean value. What is the mean value? It's 29 point something. So I can manually pass 29, or what can I do? This function or this statement or this instruction is going to give me the mean value. I'm just copying, and you can pass here like this. Execute. So it has filled the mean value. Okay, it has filled the age column with the mean value. But if I show you again, if we check the values again, the null values, I execute it here. Still it is showing the null values in the age column. Why? Because when we use this fill NA function, it is not going to make the changes in the existing data set. It returns the new data set. If we want the changes to be made in the existing data set, we can say in place equal to. Can you see in the age column, we have 0 null values now? Yes, guys. Please tell me how to handle the null values is clear to you or not. It is a very important aspect. Like, null values are, these are the headache. We have to get rid of them anyhow. So either we can drop the null values, or we can, what do? We can fill the null values. If you see the cabin column, let's read the cabin column now. In yes. So in the cabin column, we have a lot many null values. Remember, if a particular column has a lot many null values, so we drop that particular column. Okay, we drop that particular column. So let me show you how to drop a particular column. So we say data dot drop function is there, and here you can pass the column name, and you have to say access equal to 1. And if you want the changes to be made in the existing data set, then you have to say in place equal to true. So this is the function that we use. Access equal to 1 means, see guys, if it's a 2D data, a 2D structure. So when we say access equal to 0, top to down, the interpreter reads the data top to down. When we say access equal to 1, it is going to read the data left to right. Now we wanted to read the column names. So column names, it is going to read left to right like this. So that is why access should be 1 always. Fine. Now I want to delete the cabin column. Okay, I want to drop the cabin column. I say drop the cabin column. So how can we drop? I can say data dot drop, and here I can say cabin, and I can say access equal to 1. Execute. Can you see we don't have the cabin column? Guys, please mute yourself. Please mute yourself. Please mute yourself. So guys, I have muted you. So if you have any question, you can unmute yourself and can ask me. Fine. So if you can see, we don't have the cabin column here now. It has been deleted. Earlier we had a cabin column. Can you see? Cabin and embark. Now we are not getting the cabin column. But if I print the data again, see, we are still having the cabin column. Why? Because we have not passed in place equal to true. If I say in place equal to true, the changes will be fine. If I show you data, see, we don't have the cabin column. Okay, now I want to drop the multiple columns. So how can we drop the multiple columns at the same time? Let's say I want to drop this name column and ticket column together. Okay, name, ticket, and embark. These 3 columns I want to delete. Passenger ID. We can remove passenger ID, name, and ticket. Okay, drop passenger ID, name, and what is that, guys? Ticket columns. So what can we do? We simply say data dot drop. When we have multiple columns to be dropped, then we just pass the names in a list. Okay, spelling should be the same. It is case sensitive, so I am copying from here passenger ID inside the quotation mark. The second is the name, and the third is the ticket. Order may be anything, and then we have to say access equal to 1. Execute. You say passenger ID, name, and ticket all have been deleted. But if I print the data set again, if I say data, you say we are still having them. So if we want the changes to be made, permanent, then what we can do? We can say in place equal to execute. If I print the data now, you see we don't have the passenger ID, name, and ticket. So this is how we can drop the multiple columns. Is it making sense, guys, till now? So we have seen like how to handle the null values, and we have seen how to drop the particular columns. Now if I talk about the data set, so what we do actually in data set, we have different type of values. Generally we divide them into 2 categories. One is the numerical category, second is the object category. Numerical, we have integer or float values. If I talk about the object, so in object it may be string, it may be heterogeneous values. Now you want to split your data set into 2, like where we have numeric and object columns separately. so that the working on them is easy. So we can do that also. So splitting the data set into numeric and object. So we use, guys, data dot select d types function. Okay, this is the function that we use. Now, for example, I want to create the numerical data, let's say num data equal to, and I can say data dot select d types, and here we can pass numbers, just number. Execute. If I show you num data, can you see in the num data we are getting all the numerical columns now? If I say data dot head, all the rows, but only the numerical columns we are getting. Fine. If I want to get the object data, let's say I am giving the name, or let's say object data equal to, and we can say data dot select d types, and here we can pass the object. Execute, and if I say object data, we are getting the object values only, like sex and embark. Only two columns we have the object columns. So this is how we can split the data. Okay, like this. Now this is a bit I have discussed, about how to work upon the null values and all. See, guys, there are many things to do, but because of the time constraint, we cannot discuss each and every point. Okay, so what I'm trying to tell you, what is the most important things I'm trying to convey them. Fine. So let's talk about a bit about this visualization in Python. Visualization, like if you want to plot the graph or chart or something, so for that we use the matplotlib library. It is used to visualize the data. Fine. So we have pyplot module inside the matplotlib that we use. So first of all, we have to import. Okay, we have to import matplotlib. So we have how to import matplotlib. We say import matplotlib. Then inside the matplotlib, we have pyplot module, guys. Matplotlib.pyplot, and inside the matplotlib is the library name, and pyplot is the module that we use to plot the data. Okay, so any function, if I want to access from the pyplot module from matplotlib, I have to use this every time. So what we can do, we can give some name, let's say plt, and I execute. So with the help of plt, we can with any function from this. Fine, any function we can access. Let's say I am creating two arrays, like say array is np.array, and this array I have some elements 1 2 3 4. So these elements we have. Okay, this is array 1. Now I have array 2 equal to array into 5. Fine. So these two arrays I have created. This is the array and this is the array 2. Now I want to plot these arrays. So what can I do? I say plt.plot, and I can say array comma array 2. So plot is the universal function that we use to plot any data. So on the x-axis we have array, on the y-axis we have array 2, and we are getting this plot. If you see, we are getting some extra information here, matplotlib.lines line 2d, and this is the hexadecimal address it is showing. If you don't want this extra information, you can say plt.plot show function, and it is not going to show you this. Fine. This is going to give you like this. If you want to increase the size of the plot, then you can pass plt.figure object here, figure function. Inside this figure function, you can say figure size, fixed size equal to, and it takes a tuple. You can say let's say 8 by 6, execute. The size has been increased. You can increase or decrease the pixel size also. Let's say I'm saying 6 by 6, sorry, 6 by 6, and I want to increase this pixel size. So DPI, density per inches, and I say 100. Can you see it looks better now? Yes or no? So this way you can increase the pixel density also. Let's say I make it 200. Can you see it is more visible now? It is more visible. So if we increase the pixel density, size gets increased also accordingly. Fine. So let me have it as 0, 100. Fine. Now if you want to change the color, so in the plt.plot function, you can pass the color attribute, and let's say it should be red. Now the color is red. If you want the markers to be printed here, then you can say marker equal to, and different markers we can pass. Let's say first is O, we are getting the markers. Right. If you want to increase the marker size, then you can say marker size, and let's say I make it 5. So let me make it 10. So marker size has been increased. If you want to give some other color to the markers, then we can do like marker face color attribute, and let's say I make it aqua. So this is the marker face color. We can do like this. Fine. You want to give the title to this plot, then you can say plt.title function. And here you say this is the plot we have plotted. So this is the title we have. We can, if you want to give the name to the X and Y axis, we can do that also. We have to say plt.x label, and here we can say let's say we say this X axis, and this way this is the we are getting the X axis. You want to give name to the Y axis, we can do that. We have to say plt.y label, and here we can say Y axis. We are getting the name to the Y axis. So this is plt.plot, okay, plot function. That is the universal function from matplotlib that we use. If you want to increase the size of the figure, you can say plt.figure, and you can pass fixed size attribute, and accordingly you can increase the width and height. So 6 is the width and 5 is the height. DPI is the density per inches. You can increase or decrease the pixel density also. Is it making sense, my friends? So all this stuff we can do. Fine. If you want to save this figure, we can do that also. So you can say so we have to pass for one attribute like fig equal to. This is the figure attribute, and if I show you now, can you say plt.png has been created? And if I show you in the editor, this plot looks like this. Now, if you want, you can use it in your PowerPoint presentation or anywhere you can use it. This way you can save it. Is it making sense? Please tell me. Fine. Now, if we want to have a different kind of plots, so we use the seaborn actually. We can do in matplotlib also, but matplotlib doesn't, the plot doesn't look better actually. Let's say if I want to learn how to plot a scatter plot. So we can say plt.scatter plot, and it takes, plt.scatter, and it takes 2 values. If I show you the data, so we can pass 2 numeric columns. So if you say age and fair are the 2 numeric columns, so we can say like this: data.age and data.fair. what is that? Here. This is the scatter plot. This is the scatter plot. Again, we are getting some extra information. If you don't want this, we can say PLT dot show. If you want to increase the size, you can use the figure attribute in that case. So it is telling you the density. So how to read it? You can say on the x-axis we have age, on the y-axis we have fare. So fare is somewhere 500 euros. Only two people are there who are paying around 500 of euros. Fine. And most of the people, they are paying less than 100 euros. A few people, they are paying between 200 and 300. The same plot we can plot in Seaborn, but Seaborn plots, they look better. Fine. So instead of plotting in Matplotlib, what we are going to do, we are going to plot them in Seaborn. Let me show you the box plot also, so that you can have some idea. Box plot we can plot that gives us the statistical summary and outliers also. Tomorrow I will explain what is an outlier. So we can say data.h, and this is the box plot. We are getting some extra information, as I said, all this information. If you don't want this information, what we can do, we can say plt dot show function, and we are not going to get this information. If I want to increase the size of it, again I have to say plt dot figure, and I say fixed size equal to, and I can say like 6 by 8, and the density of pixels, I say, let's say 100, and the ratio, so it is bigger. Yes or no? Fine. So these are the outliers. Okay, like outliers are the data points that are significantly different from the rest of the data. Okay, so tomorrow I'll explain what an outlier is. So this is this is known as the upper whisker. This is known as the lower whisker. Okay, this orange line, it is telling the median value. This upper boundary, this one, it is telling this 75th percentile value. It tells about the 25th percentile value. 75th percentile value is known as the third quartile value. It is known as the first quartile value. Okay, so this is the box plot. All this stuff we can do in Seaborn. Fine. So Seaborn is nothing but it is the extended version of Matplotlib. So if we import Seaborn, we import like this, import Seaborn, that's it. And we can say as SNS. I mean, we have just given a name so that we don't have to write Seaborn, again and again. Fine. So we can do like that. Fine. Understood? So if I want to plot the scatter plot and box plot in Seaborn, so you can say, if I say SNS dot, we can say box plot. And if I say data dot age column, so it is creating the box plot and it is giving me the warning message. Okay, it is giving me the warning message. So if you don't want this, what we can do, we can pass the column name on the axis. Like, let's say on the x-axis, I want age, and my data name is data equal to data, execute. So you can say on the x-axis, I am getting age, and our data name is data. So we have outliers on both sides in the age column. If you want it to be printed on the y-axis, then you can say y equal to age, and you are getting it like this. Fine. Again, you are getting some extra information. You don't want this, you can use plt.show. So which one looks better, this one or this one? Seaborn looks better. So we can increase the size of it also. So plt.figure we can use. Fine. So this is the box plot in Seaborn. So we have a lot many outliers in the age column. If I want to create a distribution plot or the scatter plot, let's say, so I can say SNS dot, and I can say scatter plot, and here I can say data dot what is that, two columns we can pass, let's say age. Instead of this, we can pass as the x and y. Okay, like x equal to age and y equal to, we can say pair, and our data frame name is data. Execute, and we are getting the scatter plot like this. Again, we don't want this extra information, we can say plt dot show. We are not getting this extra information. Fine. If you want to increase the size of it, so again we can say plt dot figure, and we can say fig size equal to, and let's say 6 by 6, and I said dpi equal to 100. So size has been increased. Like this. Fine. Here, if you want to look the spread of the data on the basis of a particular categorical column. So if I show you the data, so sex is the categorical column, P class also the categorical column, survived is also a categorical column. So P class is the passenger class. You want to get the spread of data according to the passenger class. You can pass one more attribute, let's say hue equal to, and you can pass here P class like this. And according to P class, we are getting like this. Fine. But it doesn't look, very much better. So we can pass the attribute, let's say palette. And if I say bright, fine. So we can have the palette. So green is, this is the, legend we have. So yellow, blue is representing the class 1, orange is representing class 2, green is representing class 3. Fine. So you can say a lot many people, they belong to class 1, and a lot many people like who belong to class 3, they are paying less than 50 euros or something. Understood? The people who are paying somewhere around 500 euros, they are from class 1, like that. So you can do in that. If you want to get the distribution plot, okay, you want to check the distribution of the data, then you can use sns.distplot. Let's say you want to say data.age and you want to get the distribution. So by default, you are getting a histogram like this. Okay, you're getting a histogram. So I say plt.show. You can set the theme also. So if I say sns.set theme function we have here, you can pass the grid style with the name of a style attribute, and style, let's say I say white grid. So if you want the grid in the background, you are getting the white grid like this. Fine. You can pass the palette also here. Let's say palette I want to be bright so that it looks better. Fine. And scaling also we can pass with the name of context. Context we can, by default it is notebook. Different context you can pass. This is notebook, and if you want size a bit bigger, then you can say poster. You're going to get like this. So by default it is notebook, so let it be notebook. You can say white grid. You can say dark grid also. If you don't want the white grid, you can say dark grid, and you are going to get the dark grid. If you don't want the grid, you can just say dark, and you are going to get it dark like this. If you don't want anything in the background, then you can just make it white. Fine. So this way we can. So let me make it as white grid, and it is like this. Fine. So if you want to increase the font size, so we can pass the font scale attribute here. And I say, let's say I say 2. So font has been increased a bit. Let's say I say 1.5. Fine. So this way we can do. Is it making sense, my friends? Please tell me. If you want to get all the attributes, you can say shift plus tab, and you are going to get all the attributes available in this function. Now, for example, you want to increase the size of it, then you can pass the height attribute. Height, let's say I say 5. So it is already 5. So let me make it 9. So height has been increased. You want to increase the width, then you can pass the aspect attribute here, and I say, let's say 2. So you are getting this. Right? So you are getting the distribution. Fine. So you can pass the kind also. Kind by default it is a histogram. Hist means histogram. KD equal to 2. Yes, if you want the density line, then you can say KDE equal to true. Fine. You can KD equal to, so this is known as the kernel density estimation. If you don't want this histogram, okay, then both of them together, then you can use the hist plot also. So we have, let me use this theme here also. And we can say SNS dot hist plot. And I can say data dot age. Fine. So this is the distribution plot, and his plot, whether you can use the histogram or you can use this dist plot. It is up to you. So here you can say KD equal to true. You are getting this density line. And can we pass the kind attribute here? Just a second. So no, we cannot pass the kind attribute. You don't want this extra information, then you can say plt dot show. If you don't want the histogram, you want the density only, then you can pass here. So by default you are getting count. If you don't want the count, you can pass different. So you can say stat attribute here. Stat equal to, you can pass, let's say frequency you want, and you can get the frequency. STAT. It has to be frequency. So you are getting frequency. If you don't want frequency, you want density, then you can get density also. You can say density here and you can get density. You're getting density on the website. So this is you can do. If you don't want this histogram, you want the density also only, then you can use the SNS.kde plot. And you can say data.h. Sorry, it is capital. And you are getting the density. Fine. We can use plt.show. If you want it to be shaded, then you can say shade equal to true. So this way we can, use different kind of plots. So we are running out of time now. So rest of the plots I will show you tomorrow, and then we will take the case study. So tomorrow we may spend more time. Okay. So generally, I hope you have got the idea. If you want to work upon the numerical computations, then we use what? NumPy. If you want to work upon the tabular data, then we use pandas. And if you want to, work upon the visualization, then we use matplotlib and seaborn. Any doubts, my friends? Tens, I'm not sure, so I'll ask. Just give me a second, like whether the recording is available or not. Just give me a second. Yes, Vishwanath, I will tell you tomorrow, like when we're going to work upon the case study. So today I'm just telling you, how to plot a particular graph and how they are useful for us. So we will discuss tomorrow. It is not just these graphs, we have many more. So we will discuss them first, and then I will tell you with the help of case study. Fine. So now Karishma is there. So if you have any doubts related to course or the content, or whether you're going to get the recordings and all, or the data set, then you can ask her. Okay, Karishma, are you there? Karishma, can you hear me?
Yes, sir.
Yeah. Hello, Karishma. So guys, she's going to guide you. Rest we will see tomorrow. Then we will see like how to plot different kind of plots and how they are useful in our analysis. I will explain everything tomorrow. Fine.